your wristband? Do you have a hat on?
Do you have a wristband, Jada? Gotcha.
Okay, thank y'all.
I know, I'm like, dang, that was a lot. Alright, just so you know, I am collecting the questions now. Okay. Have we at least finished 3 of the 4? Anybody not finished 3 of the 4? Jada, you got how many done? You did 1.2? Okay, it's okay. We'll talk about it. We'll still learn from it, we'll grow from it, and that's what the focus needs to be. Couple of quick notes. Some of the bell ringer questions I chose were specifically because of things that I saw on the quiz. Do not forget, learning never stops. So this quiz is more of what we in the education world like to call a formative assessment. So that one, and what we mean by that is that's a chance for me to change a little bit of my instruction to help you grow, but it's also a checkup for you. It's not summative in the sense that like this is your final grade. If you take this and you learn from it and you do better on the test, cool, then you've grown, you've learned, and that's what I care about. And I will reward that on this quiz. So make sure that you're actively working on your homework, make sure you're actively learning from your mistakes, because that's how you grow. And so let's look at a couple of these things. An overall question, right, that is statistical in nature, and we'll collect numerical data. So first things first, when I look up here, we did a great job of correcting one detail. Are there any U's up here? How do you think about, or anything like that? Do you see any survey questions? No, me neither, right? So make sure that when we create an overall question, there's no U. How many states has every student been to? That is a great question. And then when you create a survey question, how many states have you been to, Grayson? Right? And that would make it into a survey question so that you can collect that data. Say it one more time. Oh, that one. Thank you. I missed that one. Dang, man, I just missed all of it. My bad. I didn't see those at first. So yes, that is a great catch. Those are actually survey questions, right? We want to keep that U out of there. That's what you would ask someone to try to get at some overall question. Kyla, do you have a question as well? That's what you're about to point out. Thank you all for catching that because I totally missed it. All right. Second thing. Does anyone see what a whole bunch of us forgot that we started talking about this week? Question mark. I mean, make sure you have a question mark. Yes. But right here. I'll come back to that one. How many states has every student been to? Which students? The what? There's a P word. Population of interest, right? Those students, are you talking about people in this classroom? Are you talking about people in this hallway? Are you talking about people at the school? Right? The population matters, right? So when we write those questions on the test, I will expect you to include the population that you're referring to. That might be something I write down in my quiz right now so that you don't forget that when you're studying for the test, right? Include your population. Write that on your quiz.
There's just so many writings already on my quiz.
I know. Well, that's your pre-assessment.
Yeah, no, it was bad. It was rough.
Did
I left
did you
like
ever,
this whole
yeah,
section
but that's your pre-assessment. That's not the quiz.
What's the quiz?
Did I give you a quiz back?
I don't think.
Did you ever take the quiz?
I don't think I took it.
So that means that when I put the grades in for you, you'll have a 0 for the quiz, but whatever you make on the test will replace your quiz grade. Unless you want to step out while we go over the quiz.
I don't know, maybe. I just don't want my mom to come up in here.
It'll be okay. Just explain to your mother. I'll make a note. Well, first off, I don't think y'all can even see.
She's gonna make me get a tutor, and she always gets a really old woman for some reason.
You could tell your mom, hey, Mr. Kinney has free tutoring, and I'll come to that.
True.
Yep. Yes, sir. Yes, you're correct. You did not as well. Now, just be aware, I gave both of you version B. Version A will have slightly different questions at certain points. So make sure you make that note to yourself of, hey, I need to make sure I include the population of interest on these questions, okay? Yes, ma'am? You don't. So notice there are number values on there, correct? The number values on there I use to calculate a grade. The grades will go into Power Schools. I do not tell you your final grade. on these papers. And I know that sounds crazy, but here's the thing. As soon as high school students see a grade, you're like, oh, that's my grade, and you move on. We don't look at the assessment. We don't look to see what we did right and what we did wrong. So I don't put the final grade on there anymore because I don't want you to care about the final grade. I want you to care about what do I understand well and what do I need to learn from. And so when you see a 6 or a 5 or a 5.5 on one of the questions, you're like, man, I crushed it, cool. Maybe Mr. Kinney still gave me some feedback, but I did really well here, right? If you see a 2 or a 3 or a 3.5, that's a, okay, I need to learn from this and I need to go back and rework these. So I want you to look at individual questions on a final overall grade. Because again, especially on a quiz, is that your final grade for that quiz? If you do better on the test, you're going to do better, you're going to have a better quiz grade, right? So don't let that define you, learn from it and grow. Okay? So that is a very intentional decision on my part. I know you want to know your grade, and you can see it later on Power Schools once they get that up and running and whatever, but that's why I don't do that. Okay, last thing I want to say, so how many bears, actually there's a couple things I want to say. How many bears are at the zoo? Which zoo are we referring to? Probably the Birmingham Zoo. Is that statistical though? No. Because there's a single response. We don't know what the response is, but there's only one amount of bears at that zoo. Could you change that question to say, how many bears are at zoos in the United States on average? Would each zoo have a different number of bears? Yes. Okay. That's how we change that, right? There's only one response at the Birmingham Zoo, and that's when you say at the zoos, right? But on average, how many bears are at zoos? Okay. How many cars will the average person have? So, I don't like to say average person because that's not really an average in a mathematical sense, but how many cars will people at Hillcrest High School have throughout their lives on average, right? Now I'm talking about an average number of cars, not an average person. Does that make sense? Okay, one last thing, so I want to point this out. How many grades are at Hillcrest? How many grades are there at Hillcrest? 4. Oh, that's not the last thing I want to talk about. So is that statistical? No. This is what I want to talk about. Yeah. How many students like candy? When I look at that question, is there a number involved? Yes. But think about the individual responses. I'm going to go, DJ, do you like candy? Yes? Is that a numerical response or is that a categorical response? That's categorical. Shannon, do you like candy? Yes? Categorical or numerical response? Categorical. Be careful, because I started to notice this on several people's quizzes. Just because there are numbers involved does not mean it is numerical. Typically, this is another note I would write on my quiz, typically numerical means there is a measurement. Typically, numerical means there is a measurement. There's one specific question I remember about dogs where I think the person asked, no, that's not the one I was thinking about. I do not. How many cars? No, that was not it either. I don't remember what the question was. But typically you need a measurement. If you look in and you see some notes about that, mostly gave feedback on the first 2 questions. Typically when we say numerical, it's a measurement. Oh, I think I remember what it was. The question was, what is everyone's favorite number? Right? The response would be a number in that case, right? Okay. But that's not a measurement. By saying my favorite number is E, I fit into a category of my favorite number is E. Typically we're talking about a favorite of something. That's going to be categorical. And because I'm going to measure how many responses are the number E. Does that distinction make sense? Okay, so be careful about that. Hopefully it's a learning moment for a lot of us. Okay. 5, 3 is a solution to 3x minus 4y is greater than 7. Woo! We're way more split than I thought we would be. How is this to determine this, the answer to this? Okay, so we're gonna, what's a more mathematical term than plug it in? There's an S word.
Substitute.
Substitute, and then we simplify. Okay, we would substitute 5 comma 3 in and then simplify. But you're going straight to a procedure there. Stop for a second, and what is the key to this question? What is this question asking? It's not asking that. There's a key word up here that tells us what we should be thinking about. Solution. Okay, that's the concept that needs to come before the procedure. When I say solution, what concept is involved there? Does it make the statement true? You got to think about that concept before you do the procedure of substituting in. Now, I can substitute in because I know, all right, I'm trying to figure out, does this make the inequality true? That's all I care about. Did 5 comma 3 make that inequality true? No. As soon as you see the word solution, does it make the mathematical statement true? That's all we care about. Alright? We got more trues than falses on this one. Negative 3 times x minus 4 equals 9. And then I said that's equivalent to x minus 4 equals negative 3 is equivalent to x equals 1. Someone who said true, can you explain to me why you said true? Maybe call you all out. Someone who said true. Huh? Okay, you didn't get this question? Ashton, what did you say?
I said true.
Okay, why?
Because if you substitute 1 in for x, all of the equations are true.
Okay, so 1 minus 4, is that equal to negative 3? So we make that equation true. 1 minus 4 is negative 3. Negative 3 times negative 3 is equal to 9. Negative 3 times negative 3 is 9. Okay, so does it make that equation true as well? Does anyone have any different reason why we should know that they are equivalent? I could divide by negative 3. Notice if I divide here by negative 3, what do I get? X minus 4. Is there anything else I need to do right now? What's 9 divided by negative 3? What did DJ just use? Division property of equality. When I ask it, are these equations equivalent, the first thing you should be thinking about, properties of equality. What else can create equivalent equations? Commutative property and distributive property. Those are the ones that we have talked about heavily. There are others, but these are the biggest ones you need to worry about. Y'all, when we hear the word solution, immediately do we make the mathematical statement true? When I hear equivalent, I'm immediately thinking about properties of equality, commutative property, distributive property. What property could I use to show that these two equations are equivalent? Addition property of equality, add by what? 4. It's not a trick, like look to see what I'm trying to get to. Hey, there's no negative 3 here, so we're multiplying, so I need to divide. Here, there's no minus 4, so what do I need to do? Add 4. So we get a 0 here, and x is equal to 1. We good for why those are all equivalent.
Teachers, excuse this interruption again. You can take roll at this time. Everyone should be in your class who was slowed down by the wreck. So go ahead and take roll. Thank you.
All right. So, are we all good through number 3 now? All right. So I see a lot of different responses. Does anyone see any of these equations that would be equivalent that we could group all together? Yes, ma'am. Yes, sir. Can I bring it 2 second block? Just because that's my planning and I'll bring it in.
Alright, cool.
Yeah. Alright, and one thing I'll point out, I think someone went ahead and kind of solved it. This would probably be an x or an m equals. Does anyone see any of these equations then that would be equivalent? They look a little different, but they're still the same. Maybe if I turn off lights, it'd be easier to see.
It might be wrong because I can't really see, but are the top two the same?
What do y'all think? 125 plus 85x equals 500 versus 85x plus 125 equals 500? Would those be equivalent? Yeah? Any others? Notice they just use a different variable, but it's literally exactly the same as the top. Any others? Now, one thing to clarify, it says 85x minus 125. That's subtracting. Do we need to subtract 125? Remember, if you were subtracting that 125, that kind of means he owes someone $125 already, so he's starting in a hole there. So we don't want that. I would also say this one. Because wouldn't you subtract 125 and then divide by that 85? Right? So that looks very different, but is that still equivalent? Yeah, there's lots of ways to do this. Someone just went ahead and worked it out. So we've got, what, 6, 7, 8 of us who all said that? Can someone explain to me why we did 85 times x? Even this one down here said 85 times x. Just missed that minus 125. Where's that 85 times x coming from?
It's multiple of them.
It's multiple of them. There's something else we need to add to that. He's repeatedly adding, right? Month 1, how much more money is he going to get? $85. Month 2, how much more money is he going to save? $85. Month 3, he's going to add $85 to his savings, right? That's what we want to recognize, is that he is going to repeatedly add that 85. That's why we're multiplying here. I personally love this notation. They're all correct, but this makes the most sense based on the context, because how much does he start with? 125, and then what's he doing to that 125? Adding 85, right? That's just something to think about in terms of the context, right? This is close to what you're used to with slope-intercept, mx plus b, right? My starting value of 125, there's my slope, my additive rate of change. Different ways to think about it. Those are things I want you to think about. I will also say that's my actual personal favorite, because m for money, right? Or m for months. Sorry, we already have the money. M for months, right? Thinking about the variables in context. We all good with all of that? Yes? That's the best yes I've gotten all year. Let's go. All right. Let's get back to today. So, really quickly, I do want to start off with a couple of details from the quiz. I'm not going to talk about everything from the quiz. We're going to just talk about a handful of things. And then we got to get through lesson 20, writing and solving inequalities in one variable. We did the first half of this already. I'll go ahead and tell you this, or the reason why we need to rush through that is because Miss Dennis is already giving her test on Monday. We'll have a different test because we cover things a little bit differently, but that means I need to somewhat keep up with her, so we have to test Tuesday or at the very latest on Wednesday. So we need to get through some absolute value stuff as soon as possible, which will be on the test, but not super heavily because it's not as important as the rest, but it still needs to be on there. This lesson 20 homework, I'll go ahead and tell you, I moved it for third block to be due next Thursday. Y'all can turn it in next Thursday as well. The one bad part about that is that means I won't be collecting it to give you feedback before the test. So what you need to do is come Monday ready to ask questions so that we can address the things that you're struggling with. Does that make sense? Okay? That's not a, what I don't know how else to say except like, it's just timing of things, right? I promised on Mondays and Thursdays. I wanted to be able to give you feedback before the test. That's just not realistic. So turn it in Thursday, but that means you need to come in to ask questions. When I looked at the quizzes, I was able to recognize, hey, this is where we're struggling with some things. That's what we're going to focus on with our exit slip today on the TI Inspire and the warm-up on Monday. But yeah, you just gotta ask questions. So that means you need to practice it. Okay, so just a heads up, 3, 4, and 5. these are the questions off version A. They probably look very, very, very similar to what you have on version B. In fact, I think 4 and 5 are exactly the same. Number 3 is the only one that's a little bit different. And I'll put version B up for the last questions. I gave you all feedback on the first 2 because I'm not going to go over those 2. I gave you feedback very heavily. Looking up here though, number 3, I was really shook to see how many of us missed this one. There's 2 things that I do recognize. The first is this. I need y'all to remember, can I add these 2 together? No. I cannot add 3x to the 5th plus 8x to the 3rd. They're not the same. Let's refresh on why. What is this multiplication right here? No, that's not the question. What is that multiplication? It's repeated addition, right? So what is this saying? I'm adding x to the 5th.
Yeah. Multiply, a little repeatedly.
I'm repeatedly adding x to the 5th
Times
3 times. That's x to the 5th plus x to the 5th plus x to the 5th. What am I doing here? Right? Can I add x to the 3rd and x to the 5th? Are those at all the same? Not even remotely. 2, 4, 6, right? I cannot add those 2 things. That's what you have to recognize. I can't add them because I can't add x to the 5th and x to the 3rd. And I just have 3x to the 5th and then I have 8x to the 3rds. Now, some of us need to be careful because I saw a lot of us do the x cubed minus 6x cubed. Are we adding these 2 things? Don't forget to distribute. The distributive property is still very alive and very well. Plus 8x cubed. I'm subtracting a positive, so I'm just going to subtract. But if I subtract a negative, that's going to become a positive. I'm going to add 6x cubed. Right? Here I'm adding x to the 5th 3 times. There are no other x to the 5ths. Here I am subtracting x squared how many times? 7 times. That's all it's saying. Subtracting x squared 7 times. There's no other x squareds there. But here I'm adding x cubed 8 times and I'm adding another 6x cubes. Okay, version B will be slightly different. Yes, ma'am. So yeah, when I say minus, it's minus 1 times that, right? So that'd be a negative 1 times 7x squared, so minus 7x squared. Negative 1 times negative 6x cubed, so plus 6x cubed. Is that what you're asking? So, x to the 3rd and x to the 3rd, those are the only things I'd be adding together. So if I have 8 of those and I add 6 more to them, that's 14. X to the 3rds. I'll pause a second if anyone needs to write a note down about that. Okay, from there, number 4, I had a lot of students talk about equivalency. Equivalency is between 2 different equations or 2 different expressions or 2 different inequalities. How many equations do I have here? Just 1. We should not be talking about equivalency here. What's the question? Sorry, 4. What points are solutions? Every solution to an equation will be a point on the graph. Some of us picked up on that or already talked about that, but I need y'all to focus on what's a solution. I saw a lot of people pick A, and I'm guessing because that's the coefficients. But if I substitute negative 3n and 6n, I get 9 plus 36 plus 5 is equal to negative 7. Is that a true statement? If it's a solution, it's got to make that equation true. That's it. You hear the word solution. Is this thing a solution? Does it make the equation true? That's what you got to focus on fundamentally. Make sure you note that to yourself. Either mentally or write it down. All I'm asking is, which ones make the equation true? I believe it was C and E, maybe? Is that right? Notice I'm not showing you the work for it. You got to check it yourself. Okay? So when we got to number 5, explain what it means for the points in the above problem to be solutions to the equation. Oh, one other thing I did want to note, because I did see a student do this. If you get to the end of this, you end up with 50 equals negative 7. First off, is that a true statement? No. So you need to indicate that it's not a true statement if you get to that point. How would I indicate that this is not true? So there's two things you can do. You can put a line through it showing that it's not equal to. Or if you leave it as equals, you can put an X or put an F or something like that to show that it's a false statement. Right? So you can either put the line through the equal sign saying not equal to, or put an X next to it, or an F indicating that it's a false statement. Okay? Either one of those would have been fine with me. Okay? So again, explain what it means for the points in the above problem to be solutions. If I hear the term solutions, what am I automatically going to talk about? Is it going to make the statement true? That's it. Every time. Okay? Equivalent equations have the same solution, but I don't have multiple equations here to determine if they're equivalent or not, right? Not asking, will these two equations have the same solution? So now talking about equivalency. Does it just make the mathematical statement true? Alright? Any questions there? Or are we ready to move on? Moving on. Alright, 6. Oof, man, y'all hurt me on this one. I did not realize how confusing this was going to be. The most common incorrect answer I saw, and I totally get where this came from. So there's the original equation, and I saw a lot, R equals 2 pi c. Can you use a property of equality to get to that equation? Nope. What could we probably have done that we're trying to do? You're trying to what? You're trying to divide something. Cool. Divide. What can we divide by? You can divide by just a 2. I saw that, I think, correctly, where someone said c divided by 2 equals pi r. Is that accurately using a property of equality? Yep. Okay, that's cool. My personal favorite, because this is something I've seen and done regularly, divide by 2 pi. Because then c divided by 2 pi is equal to r. Now, if I know the circumference, I can immediately find the radius. Notice I'm just using properties of equality there. That's it. I did give you a copy of the quiz if you wanted to take notes, right? Okay. There's no reason to do this, but could I do this? Is that legal? Yeah, where did that 5 come from? I made it up. But did I do something that made an equivalent equation? How do you know? I don't know. I used the property of equality. That's it. That's all I did. That's the addition property of equality. All I asked you to do was create an equivalent equation. It didn't matter what the equivalent equation was. I just added 5 to both sides. I did see someone do, I think 2c, they were a little off on this, because they made it 4 pi times 2r. Notice that means they multiplied by 2 twice. It should have just been 2 pi times 2r, because then I doubled, or 2c is equal to 4 pi r, multiplying both sides of the equation by 2. No one thought to do this, but I do want to point this out. Could you have done that? Anyone know what property I just used? That's a commutative property, just with multiplication. That's all that that is. Okay? So there are lots of options. 1, 2, and that's, I mean, there's technically infinitely many options because of the properties of equality you could use, but those are some examples, right? Commutative property, the properties of equality, anytime I use those, I'm creating equivalent equations. We good? Alright, not going to work all the way through number 7. You had practice with this in the warm-up. Do we see how we can make an equation out of this more easily? Okay. What would be the equation here? I can't hear you. What did you say? Right, and then you could just solve that equation, and whatever yours was, you can do it from there. One thing I'll point out, I said you could solve it any way you wanted. I actually saw someone do this very successfully. On day 1, the number of meals was 5. Day 2, the meals was 8. 3 was 11. This is a long time, but could you keep that going? And also, I want you to notice we're starting at a 5, and what are we repeatedly doing? That can help you write the equation as well. That's actually how I teach my Algebra 1 students when I have them how to start writing equations. I will point out, everyone made this mistake. If you check this, you get D equals 40. But notice that's 40 more days.
39.
It's 40 more days. Does that account for the first day? So it'd actually be 41 days. Right? It would take 40 more days of adding 3 every day to get to that 125. So it'd actually be a total of 41 days to get there. I didn't count much off for that, but that's just a detailed note. Alright, ready to get started with today?
Started, I thought we'd been started.
Well, with the lessons, we did the warm-up, the bell ringers, we did the going over the quiz. We gotta get back to inequalities today.
Can I turn in this homework from yesterday?
Yes.
I couldn't figure out the almond thing. I didn't know what was going on. I tried to put it in the problem, but it did not work. It just gave me some random
Gotcha. When's your enrichment?
Um,
Is it